transition matrices. Now let's take an example, and I'm taking the example from the book itself. Let's say there's a car company, and that car company has two outlets. The first outlet is in Bendigo, and the other outlet is in Colac. So how they've provisioned their business is, so this is a car rental company, so you can rent from anywhere and you can return anywhere because it's the same company, right? So what is happening right now is that 80% of the cars that are rented in Bendigo are returned to Bendigo, and 20% are returned to Colac. All good? And in Colac, there's a very similar scenario but different numbers. So in Colac, 90% come back. So they are rented in Colac, returned in Colac. But 10% are sent to people return at Bendigo. Right? Now in this scenario, there are two primary states. State number one is rented from where, and state two is returned to. Returned to where? Right? Now we can represent this diagram in a matrix, and that matrix is called transition matrix. So far what we have done is that we are used to reading the rows first and then we go to the corresponding columns. In the world of transition matrices, it is the other way around. You read the column first, which is the present state, and you refer to the corresponding row, which is the future state. So let's see how. So I say Colac, Bendigo, Colac, Bendigo. This is my state 1, which is rented from. And this is where it is returned to. And let's try to make a matrix. I call this matrix as T. Always, always. From Colac to Colac. Probably I'll say B and C just for mine. I mean, you can follow any order, right? This is for my brain is more used to B and C. And you can do B and C and B as well, because Bendigo is here. So 80% are rented from Bendigo or returned to Bendigo. All good, Mitchell? And remaining 20% are rented from Bendigo, returned to Colac. So your total is always 100% at a column level. Now, I don't really write percentages in this world. I write them as decimals. So this is basically 0.8 and 0.2. And they should always add up to 1. Always, always. This scenario represents Bendigo only. 80 is the loop, rented from Bendigo, returned to Bendigo, rented from Bendigo, returned to Colac. 20%. Let's go to Colac, this node. 90% collect to collect. Collect rented, returned collect. 0.9. And this is remaining 10% come back to vending. This should also add up to 1. This matrix is called transition matrix. That's my current state. Rented from, that's my eventual state, the final state, return to. Alright? That's today, that's future. That's the starting point, that's the end point. I don't care about row totals here, whatever they are. Whenever you are asked, you could be in the question asked to create a transition matrix or vice versa from one or the other. But if you are asked to create a transition matrix from a network diagram, once you've plugged in your numbers, ensure that when you add up the columns, if your column total is not 1, that means you've goofed up somewhere. Is that clear? Right? Now, yes? Alright. Now, let's go to question number 1 on 11B. Question number 1, 11B, please. And let's do part A quickly. If you've understood that, that's the very basic of it. Exactly what we've just done here. Let's try it out. You don't need a CAS for this one. So question says, when people go to the movies, they either buy popcorn or ice cream. So popcorn or ice cream are my two nodes, right? It says 85% of people who buy popcorn this time will buy popcorn next time. So what are the two states that I've got? This time and next time. So my transition matrix will have this time as columns. So I can say popcorn, ice cream, and next time is my rows, and I say popcorn, ice cream. Which yes? Tell me yes. 85% people who buy popcorn will buy popcorn. Loop in here, 85%. Popcorn this time, popcorn next time, 0.85. 85%. Yeah? All good? Come on, rest. This I don't even have to think. This always adds up to 1. How much would this be? 0.15, no? I'm not reading it now, so I know this will be 15%. I just need one clue at every node. I got the first one, I got the second one, I calculate the second one. Let's see what's happening on the ice cream end. I didn't even read the second line, I just evaluated it myself, right? 75%, now third point says 75% of the people who buy ice cream will buy ice cream. So that means ice cream is 0.75. It has to add up to 1, so this will be 0.25, no? I have not read the fourth point. Did you see what I've done? And this is what's going to be. A 30 seconds question, it should be for you next time. Mitch, did you get something very similar?
Yeah, I got it.
Yep. Gary, yes? Tom? Where were you confused here?
You said to be.
Sorry?
You said to be.
B, I said to A. Did you do this one, A? Did you do A?
No, because I thought you said to be.
I said question number 1A. 1A. Anyway, is this okay?
Mm-hmm.
Now let's quickly do part B of the question. Now part B says 80 people we're seeing buying popcorns. We're buying popcorns. It says how many of them will buy popcorns next time. So I go to my node here and say, okay, how many are buying popcorns? 85%, right? PP. So 85% of 80 people will be buying popcorns next time. So I'll say 0.85 times 80. So whatever their answer will be, those many people will buy popcorns. Rest will be ice cream. Which, is this clear? What I just talked about? Part B. Now it's clear, right? If that's clear, can we quickly do part C now? It should be quick, not even a minute. Part C, very similar to part B now. Very quick. It's on the ice creams now, that's it. Figure out the percentage, find the percentage of that number given to you, and that should be the answer. Have you got the answer? Mitch is finding it? Alright, now another 30 seconds. What's the answer, Mitch? 45 is the answer. Correct? So basically what? 60% or what was 60 people, right? 60 people of what was the percentage that we were after?
It's 15.
15%.
No, I was
No, it's 15. It's 15 people.
Oh, sorry. 15 people.
no, like it's not 45, it's 15.
The answer's not 40.
Alright. So what was the total number of people?
15.
15.
Yeah.
15 people are buying what?
Popcorn and stuff.
Ice cream from pop to popcorn.
Ice cream we need ice cream to popcorn.
Yeah.
From 15 people are there.
Yeah.
So Mitch here, ice cream to popcorn are 25% people. So I will find what? 25% of? What's this 15 talk here?
That's the answer.
Oh, that's the answer. 0.25 of 60.